In this video, I'll show you how to solve the ALEKS problem called identifying Brønsted-Lowry acids and bases. This problem is going to give you a chemical reaction and one of the molecules is going to be highlighted in red, and you have to decide if that molecule is an acid or a base using the Brønsted-Lowry definitions. It's also possible that it might not be either an acid or a base. So just going to start with a reminder of what it means to be a Brønsted-Lowry acid or base. A Brønsted-Lowry acid is a molecule that will lose an H and also a positive charge over the course of the reaction, and a base is a molecule that will add or will gain an H and a positive charge over the course of the reaction. So if we're looking at, it's actually kind of tricky to start with this first reaction, so instead I'm going to start with the second reaction. If we're looking at this reaction right here and we're trying to decide if chloride is either an acid or a base, what we want to do is think about what happens to chloride over the course of the chemical reaction. That means that we want to kind of track it through the reaction. So we want to think about what does the chloride become in terms of products. So we've started with the Cl minus, and then which of these two products used to be the chloride ion? What did chloride turn into? Does it turn into HCl, or does chloride turn into OH minus? And for this, I want you to use your chemical intuition. I want you to think about what makes the most sense. The chloride ion, does it just magically fall apart, decompose, and completely turn into two separate ions? Or does the chloride ion just pick up another atom and add another atom to the mix? So the chloride ion, in this case, hopefully you have come to the conclusion that the chloride becomes HCl. We can link those two together. And once you've made that determination that those two, this reactant belongs with this product, then you can apply these definitions of the Brønsted-Lowry acid and base. What happened to the chloride in terms of the definitions of acids and bases? Well, we can see that the chloride ion added a hydrogen ion, which is the definition of what it means to be a Brønsted base. So we'll check that box. It's easy to see that it added the hydrogen atom because it went from Cl to HCl. It's not quite as easy to see that it added the positive charge, but if you think about it, it started as a negative charge, and then we added a positive charge, and it ended up as a neutral molecule over here. So like I said, the first one is a little bit trickier to visualize. So what I'm going to do is skip on down to the next one, because this one's going to be a little bit easier as well. We're focusing this time on HCl because it's red. So what we want to do is think about, for our two products, what did HCl turn into? Use your common sense, use your good chemical intuition. HCl is going to turn itself into the molecule that most closely resembles HCl. So we want to pick, when we're looking for what did it turn into, we want to pick the product that most closely resembles HCl in terms of atoms, like what atoms are present. Once we have made that decision, we know that we can pair up the HCl with the Cl minus, and then we can analyze how did this transformation take place? What happened to HCl as it turned into Cl minus in the context of the Brønsted-Lowry acid definitions? HCl has lost an H plus, which makes it an acid right there. Okay, so let's move on down. Let's just go ahead and go back up to the harder one, this harder one up on the top. So we're focusing on H2O, and we want to ask ourselves, what did the H2O turn into? And this one's a little bit trickier to see because the atoms get rearranged in the way that we conventionally write these different molecules. So it might be easier for us to say, well, I know for sure that the Cl and the HCl belong together because that's a pretty clear partnership between those two. That, kind of makes sense. And by that logic, if those two belong together, if they match up really well, then that means that the H2O must be matching up with the OH minus. That must be the other partnership. So once we've made this decision that these two belong together, then we're going to ask ourselves, how did that transformation occur? What actually happened to the H2O molecule in order for it to become OH minus? We can see that it lost one of its hydrogen atoms. It went from 2 hydrogens down to 1 hydrogen. That means that it is an acid. And so but kind of by the same logic, this last example down here, a little bit harder for beginning students to see the relationship between OH minus and H2O because of the way we rearrange the atoms in those two molecules. But it might be easier for you to see that the HCl belongs with the Cl minus, and then just kind of by process of elimination, that means that the OH needs to go with the H2O. Once you have linked the OH with the H2O, it's a lot easier for you to apply these definitions. What has happened? We started with one hydrogen, we ended with two hydrogens. That means we added a hydrogen and it's a base.